is Nur Iman Hazika binti Muhammad Yasin. My metric number is A23A1633. First, let's look at why statistical data analysis is so vital. In today's business world, organizations are overwhelmed with massive amount of raw data, which are practically useless without organized processing. Statistical analysis serves as the ultimate bridge transforming this raw observation into actionable business intelligence. Our framework is divided into two areas, which is descriptive statistics, which use number and graph to display data attribute, and inferential statistics, which allow us to make prediction and test hypotheses using a randomly selected sample. Ultimately, they eliminate subjective guesswork and drive objective, data-driven strategies. Other than that, for business benefit and strategic implication, first, evaluating lifestyle attributes like BMI and smoking status allow insurance companies to achieve immense precision in their risk assessment and premium pricing. This creates an equitable premium structure where high-risk individuals pay rate commensurate with their actual risk. Second, by executing inferential tools like independent sample t-test and ANOVA, business can pinpoint to exact demographic and regional driver behind fluctuating healthcare expenditure. Ultimately, descriptive metrics empower companies to deeply understand their customer profile, optimize market segmentation, and forecast future financial trend and high accuracy. That's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ainuddin and my metric number is 823A2067. Today, I would like to talk about sampling and data selection step. Step 1. Extract last two digits of group members' metric numbers. In the first phase of sampling, the last two numbers of each group member's metric number were taken. Step 2. Selecting the first cases. The next step was to limit data to the first 592 observations in order to determine the case range. Step 3. Random sampling. The final sample was collected by the simple random sampling technique after the identification of the first 592 cases. Step 4. Deleting unselected cases. Once the random sample of 493 observations was found, the remaining observations not selected were discarded. Step 5. Saving the sampling dataset. The last stage of sampling was to save the chosen sample as a new SPSS dataset. That's all from me. Thank you.
Hello everyone, my name is Natasha Betty Khalid. My metric number is A23A1852. Today I'm going to talk about the section 3 of our report, which is about descriptive statistics. We are studying a group of 492 people. First, let us look at the table 1. The average age of the pupil in our study is 39.49 years old. Next, the average body mass index or BMI is 30.55. Next, let's look at the lowest and the highest number to see the gaps in our data. For age, the youngest person is 18 years old and the oldest is 64 years old. This means we only study working adults. Next, let's talk about standard deviation, which show how spread out the numbers are. For age, the numbers are balanced. For BMI, the standard deviation is low as 5.85, which means most people have a BMI very close to the average of 30. For the figure 1, which is the histogram, the graph is skewed to the right. You can see a big cluster of tall blue bars on the left side. They show that most of people only pay low cost between 0 and 15,000. For figure 2, our pie chart is about smokers. The chart shows a big difference. A huge part of the circle, 79.47%, show people who do not smoke, but a smaller group of 20.53% are active smokers. So this 20% group of smokers helps explain why we have those few extremely high costs in our histogram graph. In conclusion, most people in our study do not smoke and have typical heart score. However, a small group face very financial burdens. That's all. Thank you.
Hi, my name is Wanshafika binti Wan Muhammad Sabri and my metric number is A23A2492. So I will proceed to 4.0 Inferential Statistics. 4.1 Hypothesis Testing. For section 4.1, hypothesis testing is a statistical method used to determine whether there is a sufficient evidence to support a claim about a population. In this study, hypothesis testing was conducted to examine whether there is a significant difference in insurance charge between smokers and non-smokers. The null hypothesis HO states that there is no significant difference in insurance charge between smokers and non-smokers. Meanwhile, the alternative hypothesis H1 states that there is a significant difference in insurance charge between smokers and non-smokers. This test is important because it enables researchers to make a decision based on statistical evidence rather than assumption, ensuring that the conclusions drawn from the data are reliable and objective. 4.2 Using t-test. For section 4.2, an independent sample t-test was used to compare the mean insurance charge between two independent groups, which are smokers and non-smokers. This test is suitable because the study involved one numerical variable, which is insurance charge, and one categorical variable with two groups, which is smoking status. Based on the SPSS output, the significance value or sig2 was less than 0.001. Since the p-value is smaller than 0.05, the null hypothesis is rejected. Therefore, the results indicates that smokers and non-smokers have significantly different insurance charge, where smokers are more likely to pay higher insurance premium due to greater health risk associated with smoking.
Hi, my name is Nurin Sofia binti Jasni. My metric number is A23A7007. So for this section, I will be presenting part 4.3, which is cover the analysis of variance or ANOVA. ANOVA is a differential statistical technique used to determine whether there are statistically significant differences among the means of three or more independent groups. Unlike the independent sample t-test that we use in section 4.4, which can only compare two groups at a time, ANOVA allows us to evaluate multiple groups means simultaneously within a single test, while keeping the overall risk of error under control. The way ANOVA works is by splitting the total variability in the data into two parts, the variation between groups and the variation within groups. The ratio of these two components produce what we call the F statistic, which tell us whether the group differences are large enough to be statistically meaningful. For this analysis, selected charge as the independent variable. This represents the annual insurance premium billed to each other policyholder in Malaysia ringgit. Our independent variable is region, which classifies each individual into one of four geographic areas, which is northeast, northwest, southeast, and southwest. Because we have one numerical dependent variable and one categorical grouping variable with four categories, a one-way ANOVA is the most appropriate test to use here. Our hypotheses are as follows. H0 states that there is no significant difference in mean insurance charges among the four geographic regions, meaning all four regional means are equal. H1 states that at least one geographic region has a significantly different mean insurance charge compared to the others. The significant level adopted for this test is alpha equals 0.05. The p-value we obtain is less than 0.05. We will reject the null hypothesis. So next, we go to the table 2, shows the descriptive statistic for insurance charges broken down by region. So looking at the mean charges, the northwest record at the highest, followed by the southeast, and finally northwest with the lowest. And the overall sample means across all 492 observation is 13,252 ringgit 0.42 cent. At first glance, there appear to be some differences between the regions. However, if we look carefully at the 95% confidence interval for all four groups, they overlap substantially with one another. This overlapping already gives us a preliminary indication that the differences between the regional means may not be statistically significant. Additionally, we can see that all four regions have very large standard deviation relative to their means, which suggests high variability within each region. Meaning factors other than geographic location are likely driving the differences in insurance charges. Next, before interpreting the ANOVA results, we must first verify the assumption of homogeneity of variances. This assumption requires that the variances across all four groups are approximately equal. To test this, we use Leavenworth test. From the table 3, the Levin statistic based on the mean is 1.184. With degree of freedom, df1 equals 3 and df2 equals 488. The significance value obtained is p equals 0.315. Since p equals 0.315 is substantially greater than our threshold of 0.05, we fail to reject the null hypothesis of equal variances. This confirms that the assumption of homogeneity of variances is satisfied. That therefore is it appropriate to proceed with the one-way ANOVA. And the last is table 4 shows the one-way ANOVA output from SPSS. So let me walk through the key component. The between group sum of square is 128,694,277.7, representing the variation attributed to differences between the four regional groups. So the within group sum of square is 6.990 times 10 to the power of 10, which is the significantly larger, already indicating the most of the variation comes from within the groups, not between them. So with the 3 degrees of freedom between groups and 488 within, we get a between groups mean square of 42,898,092.58, and within groups mean square of 143,243,868.7. They give us an F statistic of 0.299. To interpret this, an F value of 1.0 would mean between group and within group variation are equal. An F value greater than 1 suggests meaningful group differences. But here, our F value is less than 1 at only 0.299, which tells us that the variation between regions is actually smaller than the variation within region. This strongly suggests that region has no meaningful effect on insurance charges. So the corresponding p-value is 0.826, which is far above our significance level of 0.05.
Hello, my name is Nur Iman Hasika binti Muhammad Yasin. My metric number is A23A1633. To conclude, our study successfully analyzed a random sample of 493 cases. Descriptively, our sample showed an average respondent of age 39 and 49 years and a general trend towards obesity with a high mean BMI and 30 and 55. Furthermore, annual insurance charges were heavily raised, averaging over 13 and 252 Malaysian ringgit, with a high-risk individual incurring immense premium costs up to 50,000 ringgit. Lastly, from a strategic business perspective, this result indicate that insurance firms should completely abandon regional or geographic segmentation where designing premiums. Instead, actuarial fairness and financial precision are best optimized by focusing strictly on individual level psychological and behavioral risk factors, specifically smoking status, BMI, and chronological age. That's all. Thank you.